Spread across some 15 million square miles of the Pacific, the 1962 Overseas Nuclear Test Series was an undertaking of impressive proportions. The test program, under the code name of Operation Dominic, required a technical and operational buildup of unprecedented scope, with planning, preparation, and deployment, all on a tighter time scale than ever before attempted in overseas nuclear test operations. And high-altitude nuclear-tipped missiles were launched from Johnston Island, with instrumentation to gather weapon effects data distributed over wide areas of the Pacific Ocean basin. Operation Dominic was triggered by the Soviet resumption of atmospheric nuclear testing in September 1961. The Department of Defense, under presidential direction, on 24 October 1962, activated Joint Task Force 8 under the command of Major General Alfred D. Starbird to prepare for a series of nuclear tests in the Pacific. During this same period, at Johnston Island, the launch center for the high-altitude program, deployment of men and instrumentation had proceeded on schedule for a first event early in May. The purpose of the high-altitude tests was to gather a wide range of effects data bearing on both the offensive and defensive aspects of nuclear attack upon incoming ballistic missiles, including warhead kill mechanisms and electromagnetic blackout effects on both radar and communications. On mile-long Johnston Island's limited acreage, crowded around and between the runway and ramp areas, were the missile launch complex and a line of more than 30 instrument rocket launchers, together with the many other necessary testing and support facilities. World War II bomb shelters were utilized for housing the command post of the Joint Task Force and other stations manned during the launch events, including those of the Scientific Readiness Team and Launch Control Units. This radar dish, scanning the sky for electromagnetic effects data, is representative of the test equipment set up and operated by the scores of technical projects. The launch vehicle groomed to carry the nuclear warheads to test detonation altitudes was the Thor missile. In the early plans, it was scheduled to do the job for 2 and possibly 3 nighttime bursts at various altitudes above the Earth's atmosphere. For these tests, the Thor was modified to carry 3 scientific instrumentation pods to obtain key data in close proximity to the burst. Each pod was ejected from the launch vehicle at a predetermined position along the missile's trajectory. The Pacific Missile Range ship moored at Johnston tracked the missile in flight for range safety purposes. Johnston's opening event on May the 2nd was a daylight certification shot, testing all systems during flight trajectory, but without nuclear warhead. This proof test went as planned, achieving all programmed objectives. But hereafter, the course of shot events did not follow the scheduled script. The first 2 hot launches did not carry through to nuclear detonation. These were initial attempts at each of the medium-high bluegill and very high starfish events. Neither of the failures was caused by the missile or warhead. On 8 July, the 3rd nuclear launch, another try for the very high-altitude starfish event, was flawless, including the performance of the many auxiliary instrumentation rockets sent into selected trajectories about the burst region. Starfish detonated at its planned strength and height, producing wide upper atmosphere glow and extensive auroral effects. Here is how it appeared from Mount Haleakala on Hawaii's island of Maui. Recovery of the instrumentation pods ejected from the Starfish missile involved pre-dawn ship, patrol plane, and helicopter convergence in the splash area, drawn by radio signals, flashing lights, and green dye. As soon as the pods were fished from the water, they were taken to the Johnston Island recovery area for removal of the scientific instrumentation. The second bluegill attempt was made on 25 July. but a one-of-a-kind missile misadventure caused by a sticking fuel valve destroyed the Thor and its warhead on the pad. The pad itself suffered extensive damage, including long-life radioactive contamination. Repairs to permit another try at Bluegill caused a significant delay. Late in October, after the last airdrop test device had been detonated, the series was pronounced a success, both in refinement of weapon design concepts developed for the Christmas tests, and in further confirmation of the feasibility of the airborne diagnostic method for future testing. With Operation Dominic completed and the test apparatus roll-up underway, the time had come to evaluate the far-flung operation and its scientific results. Despite Dominic's unprecedented four-operation complexity, with all the tests prepared under conditions of the greatest urgency in both time and circumstance, the 1962 series is regarded as the most productive since U.S. nuclear testing began. The analysis and correlation of Operation Dominic's wealth of test data will continue for some time. Nevertheless, the Atomic Energy Commission and the Department of Defense already have been enriched with vital inputs, both in new areas explored and information gaps plugged. This is reflected in the improvements of weaponry in the national stockpile, in new weapon design, and in the planning for future test programs, should the national interest require them. On all counts, Operation Dominic proved to be a significant milestone in the ever-vigilant task of keeping the nation's ramparts secure.